Morning everybody, it's the second half of the calculator paper, level 2, 2132, which you can find on the NCFE sample website. I'll put the link in the email when I've sent both parts of this recording and my workings out. Yesterday we got to the 3C. We did 3C, sorry. We got through to this next question. On question 10, we had to look at the relationship between the the ice cream sales and the temperature, and we figured that was a positive. And then we moved on to the next question, which was question 11. Again, we had to use the diagram, the 2 marks, to put a line of best fit in there, move that out of the way, and then to predict how many sales using our line of best fit the ice creams are going to be at a certain temperature. So that took us up to the start of this question, question 12. And we are looking at a frequency table. As soon as we see the equals to or bigger or greater than or less than, we're looking at a frequency table. So what I would do, first of all, with a frequency table, it's only worth 2 marks. And there's a bit of work to do with the frequency table, but the process is the same every time. So with the frequency table, the process is find the midpoint, and the midpoint is of this column. Wherever you see those kind of symbols, look at the 2 numbers and find the midpoint. And to find the midpoint, we add them both up. So for example, we had 140, add 180, and we divide it by 2. So add those 2 up, divide it by 2, and we've got, and then put the answer in there, which equals 160. You could look at those 2 numbers and think, right, there's 20 in between those 2 numbers, so the midpoint has to be half of 20, so 10 added on. And it's the same for them all. Look, 40 between there. 40 between there, so 20 midpoint, 40 between them, 20 midpoint, 40 between them, 20 midpoint. So the midpoints for that table would be 160, 200, 240, and lastly 280. And that's just saying that about 160, because it's saying some people would have had 140, some might have had 142, some might have had 179, and some 180. So it can't tell you what the exact price was. So we add the both up and divide it by 2 to then say about. So we've got about 160 pounds and times by 1 person. And then we same here, about 200 times by 5 persons. About 240 times by 7, and then about 280 also times by 7. And as you can see, I'm going to run out of space there, and I think maybe not. Let's have a look. I must move that over there a little bit more. Let me just move that over there a little bit so I can see where we got that number from. So we also got the midpoint. We times it by the number of, like you would on a normal mean, the number of. So that's the number of. We've now got a total in a second when we've added up all our midpoints. And again, it's a calculator paper, so feel free. I need to open my calculator. It's not being prepared. Calculator. And obviously in your exam, you'll have to take an official press button calculator. You can't use your smartphone, and you can't use the one on the screen. You must take in a calculator. I can use one now, but then you won't see which buttons I'm pressing. So it becomes, oh, what were you doing? How do you work that out? So 240 times by 7, 1680. And then the last one, 280 times 7. Once we've got all those figures down, we now find a total. So we're going to add all those up. This is where it becomes like a mean average, where you're now adding up all your numbers. So 1,960 add 1,680 add 1,000 add 160. Okay, so we've got 4,800. So that's, like I said, when you've done your mean average, you've added all the numbers up, which we've now added all the numbers up, and we divide it by the number of occurrences. And you can see here it's telling us the number of occurrences. So we've got the number of occurrences, which is 20 days. So we've got 4,800 divided by 20 equals, and then divide by 20, and then we can divide it by 2 in our heads and say 240 or 2,400. So we divide by 20 equals 240. And now we've done, that's our frequency, our average estimated mean amount of money per day. Luigi thinks it's over 250. Is he correct? No, because 240 is not over 250. It's quite clearly under. My workings out here would be, I would just go straight to my midpoints and go 160 multiplied by 1 equals 160. Add what's the next one? 200 times by 5 equals 1,000, and then 240 times 7, 240 times by 7. And of course, if you're working things out on a pad of paper for this one, I would say write straight into the electric box, because you're only copying out, you're not having to remember things, we're just doing a running total of these. So once you know how to find one midpoint, just write them straight into the electronic box, and it saves you kind of what I'm doing now, copying them from one to the other. And again, I was just showing the process of a frequency table on the others. So add all up, which is 4,800, divided by 20 equals 240. So we've got two, and again, it's worth 2 marks. So once you know what the midpoint is, you're demonstrating that bit of knowledge, and then you're adding up all your totals here, which we've got down to 4,800, divided by the total number. So straight away, this frequency table, is he correct? No. I show how we decide. If I'm putting here, I'm saying 240 is less than, wrong number, less than 250. So I've demonstrated that actually it's not more than, it's less than. You could put 240 is not 250. 250 is more than 240. We've shown how we decide, because we've got a figure there of 240 anyway, so they're not going to kind of ask for a sentence to say why. Luigi sells milkshakes in different flavors. Customers can order any combination of chocolate, vanilla, and strawberry. The Venn diagram shows the number of milkshakes and their flavors that were sold in one day. What is the probability that a customer chosen at random ordered a milkshake that contained strawberry and vanilla? Give your answer as a decimal. Okay, so first of all, with any probability, I'd always write it as a fraction. And once we've got it as a fraction, we know we can divide the bottom number into a top number to get our decimal. So the denominator here will be all the milkshakes. All the milkshakes is the denominator, because that's the total number of milkshakes he sold in one day. So if we go this circle first, 10, 11, 14, 15, 16, add another 9, that's 25, add another 7, that's 32. So we know our denominator is 32. He sold 32 milkshakes in one day. So what is the probability that the customer chose at random order a milkshake that contains strawberry and vanilla? So strawberry and vanilla just on its own is 5. But then strawberry, vanilla, and chocolate is 3. So it says not just strawberry and vanilla, it says that contain them both. Well, that contains them both, and that also contains them both, but it also contains chocolate. So we include those two numbers, because those two numbers both are circling the strawberry and the vanilla. It doesn't matter about the 3 of those also contain chocolate. It just says the milkshakes that contain strawberry and vanilla. So we've got 8 altogether, look. So we can see here, we've got a probability of 8 chances in 32. If we're thinking, oh, that's quite good, that's a quarter. 8 times by 4 is 32. So we can now see that a quarter of all milkshakes sold on that day was a quarter. And without dividing 4 into 1, we should know that a quarter equals 0.25, a quarter, 25%. If we weren't sure, then there is no harm whatsoever in not even looking at it as 1 in 4. You can just go 8 divided by 32. equals 0.25. Or if you did see it as a quarter, 1 divided by 4 equals 0.25. So you're still going to get the same answer. Sometimes visually you can notice things. Other times it's an exam situation. You're just churning the answers out and you forget some of the things you've learned previously, and you just do the process. So the process would be, we've got a fraction. Oh, how do I get a decimal? Oh, right, I divide my top number by my bottom number, and that's my decimal. Done. Or if we wanted a percentage, we just times that by 100, therefore 25%. Space for working, I'm just going to put 8 divided by 32 equals 0.25. And my answer is here, 0.25. So I've shown here, I've found out what it is as a fraction. I've changed it into a decimal by dividing them into each other. Done. Any more questions? No, I just thought that might, it looks like it's scrolled down the page a little bit. Cycling. Matt wants to cycle to his friend's house tomorrow. There is a 0.34 chance of the rain forecast for tomorrow. What is the probability it does not rain tomorrow? Give your answer as a fraction. So we've just done the opposite, where we've had it as a fraction, we've changed it to a decimal. Now we've got a decimal, we're changing it back to a fraction. So if we think, right, so tomorrow is definitely going to happen. It says tomorrow. So we've got a 0.34 chance of rain. So the other number, both these numbers have to add up to 1. So if we put the other number in here that adds up to 1, we can see that it's 66. 66 had 34 equals 100. So 0.34 had 0.66 equals 1. Because not rain. So, and it's not saying cloud, hailstone, thunder. It's just saying rain or not rain. Two chances. Okay, so the probability that it's going to rain tomorrow is 0.66 in 1.00. We both know that that's not a fraction. But if we change it, if we times them both by 100, that becomes 100. That becomes 66, and then that becomes 100. Now that's a fraction. That's a fraction. Does it say simplify? It doesn't. But if we were to simplify that, I'm actually putting 66 over 100 in there as my fraction. I'm putting in here 0.66 over 1. If we have to simplify that, we can see that definitely they both divide by 2. So divide by 2 becomes 33 over 50. If we look at those two numbers now, that still divides by 2, that doesn't. That divides by 3, that doesn't. That divides by 5, that doesn't. So 33 is either 11 or 3. That doesn't divide by 11 or 3. So that's the lowest, the most simple fraction you could make. But I'm keeping it as 66 over 100 purely because it does not say simplify your answer. And that's my next question done for cycling. Scroll down a wee bit. Okay. The journey takes Matt 18 minutes. He cycled an average speed of 20 kilometers per hour. So time is 18 minutes. Speed is 20 kilometers per hour. Okay. Matt wants to know how long he can expect the same journey to take if he cycles an average speed of 24 kilometers an hour. Work this out for Matt. So that's current. If he now goes 24 kilometers per hour, how long will it take? Obviously, it's going to take him less time. If we create our little triangle here, we've got speed and we've got time. So we can see when he's going 20, it takes 18 minutes. And now we've got 24 miles an hour. So this number has to go down. It has to go down. We wouldn't be going slower. We wouldn't be taking longer if we're going faster. So we need to look at how much This has gone up by, okay, it's gone up by 4, so we can't just take away 4, but proportion size, how much has that gone up by? And the best way to do it is if we look at this number here, and if I was to divide it by something, and I can see this number is going to divide by something, I can see relationships here all around. I can see the fact that this divides by 4 and that divides by 4. We should be all right here. So if we were to look at this number here and say, right, if we were going 10 miles an hour, that would have to double. So with half that, we double that. Hence, it's inverse proportion. So we know if we go 10 miles an hour, it goes to 36. If we went 1 mile an hour, we've divided that by 10, so we times that by 10. It's taking 360 minutes. Okay, now you see where I'm going. If we now go 24 miles an hour, we've times that by 24. So we have to divide this number. We have to divide this number by 24. We found the relationship by shrinking the number first. Look, we've halved that to 10, so we have to double that. And that means we've got 10 and 36. Then we've divided that by 10 to find the 1 value, Okay, we've got 36. We could have found the 1 value straight from there by dividing by 20 and timesing by 20. There's no reason why we couldn't have done that, but I did it in a simple step where we're not using a calculator straight away. So now we've times that by 24. We're dividing 360 by 24, 360 divided by 24, and it's given us 15 minutes. Okay, 15 minutes. So we can clearly see that it's 15 minutes. If we're going in here like that, we're going to do it like that. And that's our little triangle. We can see that the timing, yes, it's lower. Had we have looked at the relationship here, what have we, the percentage we've gone up by here, we would do the opposite here. But there's no need to do a calculator at every stage. We can simply look at halving that to 10, doubling that. So then once we've got 10, we can work out 1. But like I said, we could have worked out 1 from there by dividing by 20, timesing by 20. Not a problem. And there we go. We've done it. Let's go next question. Oh, no, I need to put workings out. So what would I have done here? I'd have said 10, what do you want to call it? Kilometers per hour equals 36 mins. 1 kilometer per hour equals, oh my gosh, take away, equals 360. Therefore, 24 equals 360 divided by 24, which equals 15. 15 mins. So put 5. Inverse proportion is the opposite to direct proportion. When direct proportion, say we're working on a recipe and we're making cookies for 4 people and we need, I don't know, 400 grams of flour. If we're making cookies for 8 people, which is double the amount, we just double the amount of flour. So direct proportion, we are increasing both sides by the same amount. With inverse proportion or indirect proportion, whatever we're doing with one side, we're doing the opposite with the other. So when we were timesing by 2 for one of them, we're dividing by 2 for the other one. So things like, oh, Steve's got a machine that makes 4 badges an hour. He then gets another machine. How many badges, the new machine, how long does it take to make 4 badges? So we've got 2 machines doing 4 badges an hour. So it'd half the amount of time. So we'd be kicking out 4 badges in 30 minutes. So inverse proportion is the opposite sides do the opposite thing. Let's go to the next question. Question 16. Matt decides to buy a new bike. He pays £441 and 60p for his bike. Matt reads, in 1 year, a bike will lose 5/12 of its value. In the year 2, the bike loses 8% of the value it had at the end of year 1. Matt thinks that by the end of year 2, his bike is worth less than 53% of its original value. So this is the comparison question, and kind of like a backward compound interest almost. We're finding a proportion of a portion of a portion. My first bit, and the easy bit of maths, would be to work out 53% of the original value. So we've got £441.60 times by 0.53 will give us 53%. So we times it by 53 and it says less than. So we can clearly see that we've got 441.6 times by 0.53 equals. So after 2 years, he thinks his bike is going to be worth less than, so 234.048. Less than, don't forget, means the bigger number is that number. So 234.048. This is bike's worth after 2 years. Apologies for the scribbly writing now. It's a bit doctor style. So he thinks after 2 years his bike's going to be worth less than £234 and 5p. Okay, we'll kept it as a full number because sometimes these questions are quite tight, so we'll keep it there. So let's have a look. In the first year, it loses a 12th. It's 5/12 of its value. So 441.60. Right, the bike loses 5/12 of its value. So if we go 12/12, that's how much it's worth now. Okay, it's going to lose 5/12. So it's still worth 12 take away 5. So it's worth after year 1 is 7/12 because it's going to lose that amount. So it's only going to retain 7/12 of its value. So now we know rather than go 441 divided by 12 times by 5, that's the value, take away that from the original value, we can do it in one simple step. We can go 441.60 divided by 12 times by, we need 7 of them. And that's our value after year 1. And that's simply by looking at that fraction, thinking, right, if he's losing 5 out of 12, I'm still keeping 7. So, but you can actually just work out what 5/12 is, if that's easier for you, and take that 5/12 away from the original value. I'm just trying to save you a couple of seconds. If you can understand my method, if you're still comfortable using your method, then 100% stick to your method, because I wouldn't want to confuse people within an exam. So we divide it by 12 and then we times it by 7. His bike after 1 year is now worth 257.60. Okay, and we can see that the second year, so that's our new value of our bike after 1 year. God, that's gone down some, hasn't it? Don't buy a new bike. After the second year, the bike loses 8% of the value it had at the end of year 1. So we've got a new number. We've now got to take away 8%. So this is, again, a similar circumstance above. So that's now the 100% value at the end of year 1. It loses 8% of that amount. So it's still worth 100. Take away 8 equals 92. So it's still worth 92% of that value. And to find 92% of that value, we do what we did above when we're working out 53%. We don't do 0.53 because that's 53%, but we do 257.60 multiplied by our 92% that we want to keep, because we've dismissed the 8%, we've got rid of it. We lost that bit, so we only need 92% of it. So again, we can work out 257.60 divided by 100, which is 1%, times by 8, which is your 8%, and then take that amount away. Or we can do that little short bit in our head and think, right, if it's losing 8%, it's keeping 92%. And 92% as a decimal is 0.92. So if I multiply my number by 0.92, I've still got my 92%. So times by 0.92 equals £236.99.2p, 236.992. So that's how much his bike is worth at the end of year 2. He said it was going to be worth less than 53% of its original value. Let's go back up here again. Yeah, we'll go back up here again. It's a bit, no, we'll go down because can I fit it on one more line? Yeah, I can fit it in there. So he said that 234.48 was going to be the biggest value his bike was worth, and his bike was going to be worth less than that. So we put those two numbers now in the greater and smaller than, and actually you can see that he's not correct, because the number that he thought it was going to be worth is actually smaller than a number it is worth. So that, in theory, well, that would be that way around, because that number's bigger. So we can clearly see there that when we've done it in the greater than, it's actually worth a little bit more, £2 more. But £2 is £2. Space of working out what am I doing on this one for 4 marks. I'm definitely going 441.60 multiplied. Where's my multiplied by? Less than 53, so times by 0.53. 0.53 equals 234.048. Next one I'm doing is 441.60. Take away, what we're doing, divided by 12 times by 7 for the 7/12 loss, and we've then got 257.60, and then the second year 257.60 multiplied by, don't forget, we're not we can multiply by 0.08 to find the 8%, and then take that amount away, but switch that part in your head, the bit you get taken away, take that away from 100, which should leave us with 0.92, and that equals 236.992. And I would put in here, I'd do exactly what we've done there, but I would put the bigger than the right way around. So I'd go 236.992 is greater than 234.048, because we've proven that he's incorrect. Okay, done that one. And question 17. Scroll up a little bit. Okay, Matt joins a cycling club. The 1 meter coordinate grid shows the position of Matt's house. Okay. The scale on the grid is 1 to 50,000. So the first thing I'm writing on my paper is that 1 centimeter is the same. So that's map. Real life is the same as saying 50,000 centimeters. Okay. The cycling club is 2.5 kilometers south of Matt's house. Plot the position. So south we're going down. Look, never reach, ready, wait. Not elephant, squirt water. So, oh my God, I can't draw on there. I was going to draw on there and put east, south, west so you could see. But yeah, south is opposite to north. So we know it's going to be straight down that line where we're going to plot it. So now we need to know though that 2.5 kilometers, that's in real life. We need to know what this is in real life. So if we divide that number, we know that there's 1,000 meters equals 1 kilometer. So if we divide this by 100 in a minute, I'll show you like we did yesterday. We said rather than divide it by 3,600, which was 100, which was 60 times 60 when we're doing the other one, I find it quite easy to do it in the 2 simple steps, purely because I can see what I'm doing for each step. So if we divide this number by 100, we're going to get meters. So 50,000, 1, 2, 1, 2, divided by 100 equals 500 meters. Okay, so we know now that 1 centimeter is the same as saying 500 meters. If we then divide that number by 1,000, we know what 1 centimeter is worth in kilometers. 1 centimeter is 0.5 kilometers. That helps us a lot. I mean, the first one we could probably, well, we could do it from that first one because we know that 500 meters is half a kilometer. So we could then think, all right, so 2.5 kilometers, that's 5 lots of that, because 5 goes into 2.5 5 times. So we could say, actually, we didn't need to go that far because we can work it out from here. And if that's the case, absolutely, just carry on. So we know now that we're going to pick up the point and we're going to go 1 is 500, a kilometre, kilometre and a half, 2 kilometres, 2.5 kilometres. We're going to plot it there. Do we need to write anything on there? No, there's no option to put a text box in there. So as long as we've gone south of Matt's house, so downwards, and we've gone to that line there, so 5 down, the scale is clearly here, we can see. So we don't have to write anything else, it's just plotting a point. Okay, and a 5-pointer to finish off with. Matt works out his body mass index. He uses this formula, N divided by H squared. M is the mass in kilograms, H is height in meters. Matt weighs 75 kilograms. Wow, okay, so we've got 1 in the right format, but his height is 5'11". Matt uses this conversion graph between height and meters to work out his BMI. He thinks he's the ideal BMI. Okay, so the first thing we need to do here is look at this graph, and I said this to people yesterday. I don't particularly like the fact that I've got to open something else on my screen and it just clutters it up, but that's the way NCFE are doing it. It's kind of like, so you get used to using technology and it's basically handling data. So you're finding data and then understanding what to do with it. So we can see, okay, 5'11", 5'11" inches equals, right. We haven't got a lot to go on it because it's quite a small graph. I don't know if I can make it bigger. No, I can't make it bigger, which is a real pain because I need glasses and I can't see. So we know we've got 2 points per, we've got 5 points between there, but if we know that there's 12 inches in a foot, it kind of like, well, so if we went to the fourth little one, I'd say that's as close as we're going to get, but I would go literally almost to 6 foot because we have to split that into 12 little chunks for 12 inches. So each one of those represents 2 and a bit inches, and 5'11" is close, only 1 inch off 6 foot. So I'm almost going to 6 foot and then going back along this line. Oh my gosh, I've lost my way. Up there to 6 foot, and I'm going back along this line here, along this line here. I'm getting to 1 meter, 1 meter 75, 1 meter, 1 meter 60, 1 meter 70, 1 meter 75. 1 meter 70. So this is where it's really tricky because we've got 1 meter 80 is there. Oh, yeah, I might say 1 meter 80. 1 meter 75. Oh, it's going in the middle. Okay, so it's between 175 and 180. So I'm going to say 1 meter. Let's go right in the, no, let's go 1 meter 78. Because it's so hard to tell on a small graph, but we can see that in theory it's below, it's just below, it's not quite at 180, and it's a bit, so it's right in that middle of that line there. Because we can't make it any bigger, it's really difficult. So right, we're saying that he's 1 meter 78. Whew, now we can use the formula. Meters 1.78, and it's times by 2, like it's squared. And then we've got mass 75 kilos. So we've now got, think of big mass, we need to do the 1.78 times 1.78 first. It's the indices 1.78 times by 1.78 equals 3.1684 equals 3.1684. Then we go 75 divided by 3.1684 equals 75 divided by 3.1684 equals, wow, 23.671. No, that'll do. We're not going to do any more than that. Okay, so Matt weighs 75 kilograms, yes. His height is 5'11", yes, we change it to meters. The ideal BMI is between 18.5 and 24.9. He thinks is ideal. Is he correct? Yeah, because that falls within the 20, the 18 and the 24. So I think even if we'd have gone, let's quickly, if we'd have got 180, if we'd have said 180, would that have still been within the parameters? I think it would. Equals 3.24. 75 divided by 3.24 equals 23. So it still would have been in that middle part. Then if we go to the lower end, 1.75 times 1.75 equals 3.0625. 75 divided by 3.0625 equals. So we would have still been in. That's much closer. So if we'd have gone to 175, which I said, look, it's between 175 and 180, and I can't really make it out. So 175 would have still been less than 24.9, and 180 would have also still been less than 24.9. So as much as it's important that you get as close as you can to the height conversion, we've chosen the two lines, one being 175 and one being 180, and kind of just said, right, it's in between those two, so what could it be? And we kind of went for 1.78, which is in the middle. However, both the upper end of the parameter and the bottom end of the parameter would also have had you within that range. So it's about following a formula. I'm not going to say it's not about getting the correct data, because obviously that's important too, but it shows that if you'd chosen the lower end and the higher end, you would have still been correct. So correct. Space for working, 1.78 times by 1.78 equals 3.1684. 75 divided by 3.1684 equals 23.671. So, okay, next question. That's the end of the test. So what we're going to do, we're going to have to remember again what we wrote on our, we can do some of the ones from today, obviously, but what we will do is we've still got some time to look at the ones we've done today. But because the ones we did yesterday at the very top, we'll have to try and remember which ones we were doing, because we can't fit a full 1 hour and a half into a 1 hour workshop. So hence why we split it into. So the first ones are the non-calc. Gets to question 2, and that's the start of our new one. I wrote here, it's on the map. So we plotted the hot tub mat that was going in the room on the map. Okay. Then we did 21. So as a fraction, yes. So it said that we had to look at the fraction, and you cannot put a decimal place in a fraction. So like it says there, do not accept 10.5 over 85. You can accept either of ours. Look, so I think doubling it is absolutely perfect. They've said here, accept 21 over 70. If you'd have put another fraction, which is the same as that one, they have to accept it. Okay, they're just not accepting the one with point in there. Okay, C. We're looking at the 100% value when she bought her hot tub. So we were saying how much has she saved? Was it how much has she saved? Yeah, how much has she saved? Bit of a mouthful. £70 and 51p, and we got £71, £70 and 51p. Then we looked at D, which was using the formula to work out the area of the backboard of her hot tub. I can show. Yeah, we could flip between the two, but sometimes it gets a little bit backwards and forwards. Number 4, wasn't it? So that's the area of that one. We said it was. Where was it at? Where did we write it out? 12.4, and they got 12.4. And then we're asked to fill up our hot tub. Our hot tub took her 76 minutes to fill up because we worked out the area of the circle, the depth of the hot tub, so that was the volume. So area of circle times by the depth is the volume. And then we recognized that it was filling up at 0.2 liters per second. So we had, that's where we did the divide by and divide by. We divided by, we worked out how many seconds altogether it was going to take because we divided the total volume by 0.2. That's how many seconds. Then we divided our seconds by 60 to get minutes. Then we divided our minutes by 60 to get hours. It wanted it as a decimal to 2 places, and that was 1.28. 1.28. Let's scroll to the next question. Asking us about the amount of chlorine that we needed. It rounded it up there to 26. We didn't round up, but no, yes, there you go. Or. So we didn't round ours up. It just asked us exactly how much chlorine we needed. We put it in a little window like this, and we worked our way around. We did 21 divided by 250 times by 309 equals our 25.956. The first part was a bit cheeky, I thought, visually from a person that doesn't read things very well. I read very quickly and I skip over things. I thought that those two sentences there were almost trying to catch us out. With these 1.5 tablespoons of chlorine, I then don't see. I just see the word tablespoon, tablespoon, and I don't see the 1 there, and I don't see the 1.5 there. My brain thinks, oh yeah, tablespoon, tablespoon. So 1 tablespoon is 14 grams, so it must be 14 grams. But don't forget, that's where we had to work out 14 grams times 1.5 to start with. So we worked out how much 250 gallons needed in grams, not tablespoons. So we did it that way around. That was our answer anyway, was the same as what they had. We had the more detailed answer. Then we went to a 3A, which was the angle of the ice cream wafer, 45 degrees. He said that 8 wafers make up a full circle. So we divided the full circle, which is 360, divided by 8, which was 45. And I did my little diagrams there for you. Then we were asked how many ice cream tubs will fit in his freezer. That must be question 8. Yep. So big box, little box. How many little boxes fit in a big box? How many the shipping container one, the candle question. So you can see here there's a common theme there where, out of the last 3 exams or last 4 exams, there's been 3 questions where it's asked you how many little boxes fit in a bigger box. And the simple way to work that out is like I did, just visually draw it. And this is like millions, which is not. So we visually drew it. We worked it out as 6 per layer, 9 layers, 9 times 6 is 54, 54 tubs. Correct. Alternative method, now we use that method, another alternative method. So 3D was, is it a positive correlation, a negative correlation? It was going up from left to right, therefore it's a positive correlation. It doesn't have to have the word strong in there. You could have just written positive, and I wrote correlation, but again, it's showing you don't need the word correlation. You can just put positive. However, if you weren't sure for positive or negative, and you visually see that the more ice creams are sold is when it's hotter, then write that. It's asking you for the relationship. So mathematically, yes, it's a positive relationship. Visually, when you read the graph, the hotter it is, the more ice creams we're selling per day. So that's why it accepted all those different answers there. 3E, we why did we put 72? I'm trying to think. Ooh, let's have a look. 3E, the next one, that's ice cream. That's the selling. Luigi records. No, that wasn't it, was it? Next one. Oh, we're asked to write how many ice creams. Okay, how many ice creams we're going to sell. I'm thinking, where does 72 come from? So it said tomorrow the temperature is going to be 23. How many ice creams are we selling? We said 72. They are accepting between 69 and 77 because, like I said, it's your handling of data where you put your line of best fit. Obviously, a little bit higher would be up to 77, a little bit lower, they're saying up down to 69. As you can see, we were pretty much bang in the middle. We were 3 up from the base and then 5 down from the height. So, if we'd have written 73, that'd be bang in the middle. But that doesn't matter. The fact that they're giving you some parameters to work with, that they're showing you examples of where they're going to take your answer from. So we were quite clear. We drew a line of best fit and then we worked up and along and we got 72. So that was the end of yesterday's session. Today's session, we started with, let me go down a question. We started with the frequency table and we were asked to say, does he make that much money per day? And we said no, because he makes £240 a day, not 250. So no and 240. Again, it's showing you all the midpoints times midpoint times midpoint. Full amount, 4,800 divided by 20, and we've got 240. So it's showing you the process of what you would write in that box. Sometimes these get a little bit complicated, hence why I show you what I write on my paper, and then I copy what I think would be useful in the electronic box and what's going to get you those marks. So yeah, because it's only worth 2 marks. So all your midpoints up to what you've got, 4,800 divided by 20 is 240. Next question was about, let me go, next question, we got that one correct. Next question, we're saying about the ice creams. So which one was it? We have to put it as a decimal. We said 0.25 and they said 0.25. They've given you, have they given you anything else? No, they're not giving you, they're giving you 2 marks for showing where you got your numbers from. So we said 32 was the denominator, 8 was the numerator. So they've got the same as us. Let's go next one. Where's it going? 4. So then we went back onto cycling. It said rain today, or not rain today, tomorrow, sorry. Not today, it's blue sky today, amazing. So 4A, we said 66 chances, 0.66 out of 1. We converted that to a fraction and we just times both sides by 100. We said 66 out of 100. We did not reduce it. We kept it as that. If we were asked to simplify it, we would have put 33 out of 50, but I would be more than happy saying 66 out of 100, which they are as well. Had you put 33 out of 50, they're accepting equivalent fractions, and that is an equivalent fraction. 15 minutes for the time to when it's going faster. They've done it here. Look, 18 times by 20 divided by 24. So if you're working with this primary school window method, you can clearly see 18 times by 20 divided by 24 equals 15. They can go around in a circle, and that's a really easy way to work it out. If you're again, if you're visually looking at reducing the number to what you can work it with, a 10, then a 1, like we did, then absolutely. But again, if you're dividing that one by 20, times it by 24, you can get that answer, the 15 minutes. It's just noticing which way around to go in that little primary school window and where your gap is. Question C, let's go C. So we did the vanilla ice cream, we did cycling, we did rain. We now on 16 and we got incorrect. Question C is incorrect because his bike's going to be worth slightly more than what he thought, 236,992. And we got 236,992, exactly the same. So we can see that yes, it's going to be worth more, but he said it's going to be worth less, so it's incorrect. So it's a no, he's not correct. And then we've got, God, there's a lot, look at that. So for me, we worked it out. In the way, again, I logically saw the process, but this is where maths shows there are many ways of getting to the same answer. So alternative method 1, yeah, alternative method 2, 3, 4, 5. They've shown 5 different ways to still get a no. So it goes to show maths is not a one-way thing. If you've got methods you're comfortable with and I'm confusing you with my methods, by all means come to a drop-in and say, Steve, I don't do like that. I do like this. Amazing. It'll teach me something that's really good, because there's lots of ways to do things. For D, we then plotted the map down there. I mean, he's give you the coordinates there. Does it say we have to write the coordinates? I didn't see that option to write coordinates. No, we don't have to write the coordinates, but we can see it's 5 along and 3 up. So along the corridor up the stairs, 5 along, 3 up. Yeah, they just wrote that obviously because they can't visually show you it. And again, they've worked out their kilometers slightly differently to us. 2.5 divided by 50,000 times by 100,000. That to me is too many 0.000. That's too many zeros. For me, working it out again visually, 1 centimeter, 1 centimeter, 1 centimeter, keeping my map the same, but each time reducing the number here to go from centimeters to meters to kilometers. That helped me visually, and it's just, yeah, for me, it's what works, I suppose. Let's see what height they said they were going to be. One, all right, so they've got better eyes than me, much better eyes. They've said 1.775. 1.775. We rounded ours up to 178, even though it was really, really hard to see on there. So they're going to accept anything between 1.7 and 1.804. So that goes to show the parameters they were willing to accept. And we worked it out for both those, and we saw that actually he was in the ideal range, whichever method we chose on there. And again, it's giving you 3 different ways to work that question out. And that is the end. So if there are any questions on here, you're thinking, that's really baffling, Steve. I don't know how you're getting that. I can't see it. When I work it out, I get something completely different. Please remember what question it was, and just give me a shout, and I'm happy to go through things and break things down and write as much as I can, explain as much as I can, and until we kind of understand which part it is you're not getting, which step it is. It might be that I've gone too quick over a step, or I've done something in my head, and you're thinking, where did you get that bit from? Please do shout out, and I'm more than happy to help via phone call, video call, email, text, WhatsApp, however you want to get in touch with me, please do. That's all for me. If you're in my class later, look forward to seeing you all. If not, enjoy the blue sky if you've got it, and I'll speak to you all later. Bye bye.